In this video, Anna describes how she plans for a unit of instruction. This kind of planning involves 3 practices that build upon one another. The first practice is unpacking and prioritizing the science ideas in the curriculum and the standards. The second practice is identifying an anchoring phenomenon and developing a causal explanation for it. The third practice uses this causal explanation together with the standards to develop a sequence of learning activities for students. It's important to note here how intentional she is about designing a series of learning experiences for her kids.
I mean, we were really looking at the next generation standards to sort of drive what we needed to cover, I suppose. Our focus for all of chemistry was essentially the makeup of matter, so the idea of molecules, of everything being made of molecules, and the nature of that. So I suppose that this unit I really saw as a sort of a validation of the fact that everything is made of molecules. So a phase change is nothing more than a change in what the molecules are doing.
You and I had talked a few months ago about these standards before you started to teach. What do you see in the middle school matter and interaction standards that you could target for your unit?
This particular standard reads, gases and liquids are made of molecules or inert atoms that are moving about.
Anna has identified several applicable standards for her unit. These are drawn from 2 different areas in the standards. One set of ideas is about temperature and the kinetic energy of particles. Another is about changes of state. Anna also has identified 2 performance expectations. One is about planning investigations. Another is about creating predictive models. Because ambitious science teaching always includes modeling and evidence-based explanations, she is comfortable with the science practices embedded in these performance expectations.
So this particular unit that was based on the soda pop distillation was really focused on being able to identify each state of matter, not just as a descriptive thing, but also as something that could be changed into another, I suppose. So comparing those and really focusing on really just their molecular nature. So, and then another big one that we ended up, and this was kind of student driven, but we really ended up focusing on defining heat because kids were really focusing on, pulling from here just the atomic nature, the molecular nature of matter, and then also what type of energy can exist, and linking a type of energy that they already have some ideas about, the movement energy, to another concept they think they're very familiar with, which is heat, and sort of explaining what that really is using the idea of molecules.
You picked a puzzling event or a phenomena to anchor this whole unit. Can you describe what that was?
Yeah, for that unit, we decided to distill soda. So we distilled, in my classroom, we distilled Coca-Cola and 7-Up, and then we actually captured the distillate as well. So we ended up with water that had been boiled off and then a nasty syrupy chunk that didn't move. And so that was sort of to show them what was in soda. But it was also because it was we don't have distillation equipment, so we made it up.
Yeah.
So we used 2 Erlenmeyer flasks and connected them with some plastic tubing. So there was a lot of popping off and steam going everywhere, which at first I was very concerned about. But in the end, the steam actually was a very good, a very good observation to point and say, what's that? What is steam and why is it foaming out of there? Not foaming, but why is it blasting out of there with such force? So that was an exciting lab day. that we spent, I think, about 4 weeks trying to explain. Yeah, so.
But you covered a lot of territory.
Yeah, we did.
In 4 weeks.
Yeah.
What did you expect kids to be able to do at the end of this unit?
So one of the main things that we wanted students to be able to do was not just explain why the water boiled off or why the syrupy stuff stayed behind in the soda, but really we wanted them to be able to draw it. So we wanted them to take what they had learned in the previous 2 units, which was really just drawing really static looking models of a zoom in of water. You know, they would draw motion lines on a molecule, but it was just sort of like a snapshot. And we really wanted them to be able to, maybe with others or maybe by themselves, make a model that didn't just show a snapshot of the soda at any given time, but really show how those molecules were moving and how that was changing as time went on, and how more heat changed the way the molecules moved, and really connecting the idea of more heat to the molecule's motion. So really starting to equate those things instead of talk about it like a cause, like more heat causes molecular motion to increase, but really equating those things, as opposed to just focusing on different states of matter. So really focusing on the gray area between how when the solid changes into a liquid, what is actually happening, and being able to actually map that out and draw it as well as explain it. That was our focus.
So you have a kind of a before, during, and after kind of a model.
Yeah, we started the soda frozen because we wanted there to be a solid that the kids would identify as a solid. We weren't sure if they would call the syrup a solid, and we weren't really at the beginning sure if it was a solid. And so we started it frozen. So we had hot plate is off before, then we had frozen Coke starts to melt, and then we had Coke is boiling, and then we had all of the liquid is boiled off the Coke, so that we could focus on the pure water, which wasn't pure water, but and then the syrup. So those were our 4 time points that we looked at, and we chose those specifically so that we could focus on each phase change at a different spot.
Up to this point, Anna has described her work with the standards and identifying big ideas to teach. She has also selected a phenomenon that is complex to explain, and she developed a question that can engage her students over time. To complete her planning, she uses the final practice that begins with writing out the explanation for herself. This explanation can be written as just beyond what she would expect her students to construct. Here we color code all the component ideas in this explanation. Each of these should be addressed in 1 or more lessons. Anna selects lessons, then, that are matched up with these parts of the full explanation. The last step is to rough out which of the activities and key readings would fall into the first third of the unit, the middle third, and the final third. This process represents how we plan for ambitious science teaching. If all the steps are followed, we can be confident that we'll be focusing our teaching energies on truly important science ideas, that students will be challenged, and that each lesson will clearly build toward a significant understanding of how the natural world works.